talk that I gave at the Citrus Institute in Avon Park a couple of weeks ago, but wanted to repeat it here just in case some of you couldn't be there. But we've noticed over the last few years, Jim Graham and I have been working on this bicarbonate issue with some growers, and we've known for a long period of time that our soils are underneath the citrus trees that the pH was increasing. This goes well before greening occurred, but we didn't see much effect on the higher pH under the trees on our citrus trees until greening came along. So we started looking at this because of the initially because of the reduced reduced root density underneath these trees, looking at other stress factors. Perhaps this buildup of alkalinity from bicarbonates is a stress factor that also affects the root density. We're not sure that happens right now, and we're quite, to be honest, we're not sure exactly what is causing the leaf loss or how we can prevent it, but we know that relieving any stress to these trees, particularly associated with soil, it will improve their growth and their productivity. So in addition to water irrigation scheduling, we started looking at bicarbonates. And bicarbonates have been an issue in the West for a long time. There they have much more severe bicarbonate issues. They have natural bicarbonate levels in their soils that limit production of various crops. But again, going back to some of the literature, we didn't see that happening much in the way of citrus. But what we do see is that in crops that are sensitive, the number for bicarbonates is about 100 parts per million. If your irrigation water is less than 100 parts per million, you won't see much in the way of buildup of bicarbonates, pH change, or effect on the trees. If you are over this 100 parts per million, you will see gradual buildup in the soil and effect. So the alkalinity is simply the presence of bicarbonates in the soil under Florida conditions. These bicarbonates neutralize any natural acidity in the soil, causing the pH to increase. And these alkaline compounds in the water remove hydrogen ions and lower the acidity of water. They can limit the nutrient availability for many of the crops and many nutrients, and we'll go through that. What results is that if you have water of pH of 7.5 or above with high bicarbonates, the bicarbonates are typically associated with calcium, magnesium, sodium, and potassium. These can accumulate in the soil. You can have very high calcium concentrations in the soil, but very little of that calcium concentration is available. And that can also precipitate out other nutrients such as phosphorus, so that it is no longer available to the tree. These effects can affect the physiology of the roots, reducing their ability to uptake nutrients. You can treat the soil with gypsum, calcium sulfate. This will not increase the pH, but will provide available calcium to the soil. The better result, we think, and we've just started this research, so we don't know conclusively, but use of elemental sulfur to reduce the pH of the soil is something that can be done. However, we've tried this in some high pH, high calcium soils further south, down in the Immokalee. The effect is very short-lived. We can get about 45 to 60 days out of about 500 to 1,000 pounds of elemental sulfur per acre. We get about 45 to 60 days out of that, and we're right back up to the pH where we started from. So it's not a good long-term solution, or certainly not a good short-term solution, but we don't think it's a good long-term solution. The better way is to acidify our irrigation water. By acidifying our irrigation water, we're reducing the bicarbonates that are accumulating in the soil, reducing the pH of the soil around those roots because of the acidity we're adding to the soil, and we're making nutrients available to the tree. I'm sure many of you have seen this chart in soil and nutrition texts, but this chart indicates the relative availability of nutrients at different pHs. So going from a pH of 4.5 up to a pH of 8. The width of the bars here determine or illustrate the amount of nutrients that are available. The preferred range for citrus is 5.5 to 6.5. You can see that that's where the majority of these nutrients, with the exception of iron, are most highly available. Zinc, manganese, zinc, molybdenum are towards the end of that scale, but we don't want to be there because that reduces the amount of nitrogen, potassium, and phosphorus that is available. So the preferred range is 5.5 to 6.5. Most of our soils now are creeping up into this 6.5 to 7.5 range, and a lot of them over 7.0. You can see that iron, magnesium, manganese, and zinc become very limiting, as well as boron at those pHs. So just uptake, along with the reduced root mass, are causing problems with the uptake of these nutrients in our soil. So if we can get the pH of the soil from around 7.5 back into 6.0 to 6.5 range, we can make more of these nutrients available. The downside is we also make copper more available. We all know that we've built up copper in some of our soils, particularly fresh root grows, and now because of canker and other things, we've applied a lot of copper that have accumulated in the soil. If you have high copper, you need to be very careful about going below 6.5. But going anywhere from in this range of 7.0 to 7.5 down to 6.5 will certainly make nutrients more available and probably should not give you a problem with copper toxicity. Looking at plant uptake, just to illustrate some of these things, there's always been in crops that are sensitive to bicarbonates, we've seen that there's a Lyme-induced sclerosis, a yellowing of the plant as you increase the pH of the soil. These two graphs look at iron and zinc. As you go from a pH of 5 up to 7, the amount of iron and zinc in solution goes down dramatically. So it's just not there, it's just not available to the plant at pHs near 7. Very, very limited availability. The carbonates can affect growth. There's been some studies looking in the literature that high bicarbonates will lower photosynthesis rates in plants and reduce the amount of chlorophyll in plants. As I mentioned, we look back at the literature going back all the way back into the 40s. We didn't see, well, I should say we saw comments in there, particularly in California and Arizona, that there were high bicarbonates in the soil, but for the most part, they didn't see a big effect on tree growth and tree production. But we know from what we've looked at here just recently that we have a big effect on iron, zinc, and manganese, and these are the nutrients that we the deficiency of these nutrients are mostly associated with greening. Looking at some studies We did notice that the trifoliates, chorizo, swingle, and others are more sensitive to bicarbonates. The rootstocks that were used 20, 30 years ago, sour orange, rough lemon, those are not as sensitive to bicarbonates, but obviously you have tristeza and blight issues with those rootstocks. This is a study published by Castle and others looking at the amounts of bicarbonates in the soil and the relative effect. They looked at fresh weight of the biomass, the upper part of the canopy. They looked at growth of the canopy and leaf greenness, and they ranked them as the least affected to most affected. Least affected was Cleopatra, mandarin, sour orange, all the way down to Vulcamariana. And then the most affected was swingle and the trifoliates. These are some water quality limits that I found. The pH of water, irrigation water, that in the literature typically is 5.5 to 7.0. That's what you want to see in your irrigation water for most plants. They can become phytotoxic if they're below 5. So you have to be careful about acidifying water too much. Several growers have asked me, instead of constantly acidifying their water, can they just apply a large amount of acid all at one time, try to reduce the pH of the soil, then go back to their regular irrigation and repeat this every so often, every month, a couple times a year, whatever they want to do. You do run the risk of phytotoxicity if you go below pH of 5, but the soils are so highly buffered with the bicarbonates that are in there, even though you're applying water below a pH of 5, that pH will not stay that low for very long. Within a matter of hours or days, you're back up above pH of 5. So yes, you can do some damage, and that should be monitored very closely. So we're not recommending slug applications of acid at this time, but it is something that could be done. And these are just numbers of alkalinity and bicarbonates in the water. As far as milligrams per liter of calcium carbonate, you want to stay below 40 if possible. A lot of our soils are well above that. And you want to stay under 90 milligrams per liter of bicarbonates. And that goes back to the graph I showed, or the figure I showed earlier, where we want to stay under that 100 parts per million number. Acid treatments, as I've mentioned, you want to try to get it down below 6.5, but you have to be careful of your copper content. Phosphoric and sulfuric acid are cheap materials that can be injected. There's a lot of caution that should be taken using these materials. They can be hazardous if they're spilt. They can be highly corrosive to pumping equipment, but they can be used. They're infuric type of products where urea has been added to sulfuric acid is a good alternative. One, it's adding nitrogen to the soil, very small amount, but it adds some. But it reduces the harmful effects of the sulfuric acid on the people applying the material. So if you accidentally spill some, you're not going to get hurt as badly with this material as you would with sulfuric acid. This is looking at water treatment and what we're actually doing when we're treating water with acids. The pH running along the bottom of the chart here from pH of 4 to 14. You look at the percent of total amounts of these three components in water. you have carbonic acid, bicarbonates, and carbonates. If most of our water is in a 7 range, you can see that the acid is very low. The bicarbonate is very high, would be very high. So if we shift this pH over towards 5, we'll have much more of it in the acid form and get rid of the bicarbonates in that process. I've mentioned enfuric. That's a safer way to go. Use of gypsum is also a possibility. It won't affect the pH, but it will provide calcium that are needed by our plants and quite often deficient in our trees, particularly in greening trees. Looking at sulfur, we've mentioned sulfur. A lot of growers would like to do that, apply sulfur or have sulfur added to their fertilizer mix and try to lower their pH gradually over time that way. That's something that can be done. The amount of actual elemental sulfur obviously increases with your initial pH and your target pH. So if you start off with a pH of 8.5 in your soil and you will go to 6.5, in sand soils, the approximate amount of elemental sulfur you will need will be 370 pounds per acre to make this shift. And it will go down 2 pH units very quickly, but again, it can rise quickly after that. If you start off with a lower pH, somewhere around 7.5, and go to 6.5, you reduce the amount of sulfur required. Now, if you want to go to an even lower level, like 5.5, from 8.5, that's 3 pH units, you're going to more than double the amount of sulfur that you have to apply to do that. So in conclusion with this, we're just starting to look into this issue, the bicarbonates, and how that affects our trees, particularly with greening. We have some studies going out. They're just in the beginning phases where we're applying different levels of acidity to irrigation water to look at the effects on soil, pH, bicarbonate levels, nutrient availability. We're also looking at the trees to see what the effect will be on the nutrient status of the trees, if we can get more of the nutrients into the trees, and then ultimately yield and fruit drop. We'll look at that to see how that affects the trees as well, the reduction of the pH. And we're doing both by acid and by sulfur to get an idea of which is more effective. Now, I just wanted to quickly show you this. I've talked about previously some of the work that we're doing that's supported by CRDF, Southwest Florida Water Management District, and DAX. The field project, this is an example of a unit that we've developed containing the acid and a proportional injector going into the irrigation system. That project is supported by CRDF. We're just getting those out in the field. We have a scale project that I mentioned before in the greenhouse so that we can keep trees HLB free and HLB diseased and look at relative water uptake. We will also be looking at some carbonate issues in those trees as well. So, be glad to answer any questions you may have. Okay, well, I appreciate your being here today and your attention. Anything we can do, you have my contact information. Just give me a call anytime. Be glad to come and talk to you, go to your grove, see what. So, be glad to answer any questions you may have. Okay, well, I appreciate your being here today and your attention. anything we can do, you have my contact information. Just give me a call anytime. Be glad to come and talk to you, go to your grove, see what we can do. Yes?
I just want to make a point with respect to the weather stations.
I'm sorry?
With respect to the weather stations and cooperative funding.
Yes.
I'm with uptake. We don't have funding for it right now. Susie Bishop is accepting applications
Right.
for the new fiscal year starting in October.
Right. Right. That's the DAX funding starts in July, but they have to have some time to put that system together. They've run out of money for this fiscal year. We have put in about 65 to 70 weather stations this year on that cost share money. We don't know for certain, but we're right. That's the DAX funding starts in July, but they have to have some time to put that system together. They've run out of money for this fiscal year. We have put in about 65 to 70 weather stations this year on that cost share money. We don't know for certain, but we're definitely hoping that there'll be additional money for next fiscal year. Okay. I'd like at this time to ask our sponsor for. Right. That's the DAX funding starts in July, but they have to have some time to put that system together. They've run out of money for this fiscal year. We have put in about 65 to 70 weather stations this year on that cost share money. We don't know for certain, but we're definitely hoping that there'll be additional money for next fiscal year. Okay. I'd like at this time to ask our sponsor for lunch to come up and talk about their products.
This will be short and sweet.
Okay.